This is the USB bug detector. It's a small device which allows you to figure out if the device you connect over the USB port includes an integrated circuit or some kind of active device. And you can even simulate it by pressing on the simulate button, and you see that the LED is now on. This way you now know that the USB bug detector works and that the battery is not empty. And when you press on the red button, you can go to the next test. And for the first test, we will use this small device. This is a micro SD to USB adapter. And when you plug it in, it also detects it as bugged. It means that in this device, there is an integrated circuit. And it's the one which allows you to read the micro SD card over the USB port. So it is kind of expected. And here, press on reset. Let's now have a look at this one. This is a plain micro USB cable, nothing fancy. And if I plug it, it doesn't detect that it is bugged. This is just some wires. There's no integrated circuit inside. If we have a look at this cable is a bit larger on the plug, and it actually integrates a USB power meter. And if I plug it in, it goes on and it shows the voltage on the USB port and how much current the device on the other end uses. And if we connect this device to the USB bug detector, it detects it as bug, but it doesn't provide enough power for the device to switch on, because if it's a malicious bug, we don't want it to be powered on. So let's reset and let's go to this cable. This is yet another micro USB cable where you can use to charge or to transfer the data. But if we plug it in, the bug detector indicates that it is bugged. And if we have a closer look at it, we see that this cable includes a large integrated circuit. This integrated circuit could hack your computer over USB, for example, or it could even have a SIM card, and the attacker could remotely control this device and then remotely control the computer, or even use the embedded microphone and then just tap to your conversation. But thanks to the USB bug detector, we figured out that this cable is malicious. So it allows you to increase the security of the computer, your network, and your company. And once you finish testing the devices, press on the red button to save some power, and there we have it. Let's have a look at all the versions available. This is version 0. This was my proof of concept, and I used it to test if the idea I had to detect integrated circuits was working. And this device works. It's a bit larger. It uses also a larger coin cell, LCR2032, and it has multiple footprints to have this chip in multiple packages. But it also works. When you press on the test button, it does the same test, and when you press on the reset button, it's ready for the next test. Once I had the proof of concept working, I created version 1. It's a lot smaller. It uses also a smaller battery, but it still lasts a couple of years. And it is big enough for the instructions to be on the back of the PCB. When you use integrated circuits, and in this case a microcontroller, you very often find these tiny devices next to it. These are decoupling capacitors, and they're vital for the stability of the operation. And next to voltage regulators, you also find them. And again, they're very important to have a smooth voltage regulation. So you find them very frequently on these boards. This is also a capacitor in a slightly larger version, and it has 100 nanofarad, a value which is very frequently used for decoupling. And when we enable power, we see teeny tiny peak. It is very short, but it uses 100 milliamp. And this is when the capacitor charges. And using a resistor, we can turn this tiny current draw into a voltage spike. If I press on the button, here you see the voltage spike as measured by the oscilloscope. This is the entire circuit for the USB bug detector. Here we have the battery. It provides power to VCC, and then the power is fed to this USB receptacle. Now, when the USB device is connected, it will use some power which goes back to ground and then through this resistor. And this resistor turns this power consumption into a voltage. And the voltage is sent to this S signal. The S signal goes to this RS latch, which is based on 2 NOR gates. RS stands for set and reset, and then it latches the value. So as soon as there's a small voltage on the set line, the output Q is set high until a signal on the reset input is sent, and then the output switches off. So what happens if something is connected, there is a small current draw which is transformed into voltage to this S line. It sets this RS latch and the output is set high. The output Q enables this LED, the bugged LED, which you see on the circuit. And we can simulate this IC using a small decoupling capacitor. This is what you see here. It just connects the decoupling capacitor to the S line as the device on the test would be. And then the second button, the reset button, sends the signal to the R line, and then this turns Q off and the LED is off again. And by the way, the USB bug detector is open source hardware, so you can find all schematics and board layouts for all versions on the CuVoodoo repository website.